Hi everyone, today we will be looking at a comparison and teardown between two switch mode power supplies, specifically between a cheap made in China unit as well as a proper brand name unit made in Japan. I was recently working on a project that requires a 24 volt power supply, so I searched around for a compact unit type enclosed power supply. A quick search led me to a wide variety of very cheap switching power supplies on eBay for only a few dollars. So this is one that I picked up. It's only $8 and this was including shipping. So this is very remarkable considering how expensive a good brand name one like this costs. This one is a Cosel power supply and it's a good brand name power supply and made in Japan. The difference is that this power supply would cost about $85 new on Mauser. This led me to ask the question, what is the difference between a cheap China-made power supply and a good brand name one? Both of these units are 24 volts at 2 amps, so they're both about 50 watt units, but one of them costs $8 while the other retails for 10 times the price. Let's do a quick teardown to investigate and measure their performance. Before I do a teardown, I wanted to do a quick comparison between these two power supplies, so I made a small chart describing some of the various features. For the first one, this is a made in China power supply. It's rated 48 watts, so that's 24 volts at 2 amps output. It's very compact, being only 36 by 78 by 111 millimeters and weighs just about 170 grams. As you can see, it is very small and very compact. This cost me about $8 on eBay, including shipping. It has an input rating of 110, 220 volts, plus minus 15%, so we can consider it a universal input. However, there are no data sheets that I could find for this particular unit, so we have no idea what sort of ripple we are expecting, we have no idea what sort of regulation we are expecting, so these are some of the things that we'll investigate. Now let's compare that to the brand name Cosel power supply. As you can see, this is a PAA50F24. So this is from Cosel's PAA series, which is their flagship series. This has been recently replaced by the PBA series. And as you can see, this power supply is significantly larger and it weighs a lot more. And I hear that in the new PBA series, they've actually made that smaller. So let's take a look at their specifications. So both Cosel units are 52.8 watts and they're rated 24 volts at 2.2 amps. This current unit that I have is quite large. It's 37 by 85 by 159 millimeters. And according to the data sheet, it should be no more than 400 grams. I measured this to be just about 380 grams. Now, in the new PBA flagship series, they've actually made it a lot smaller. And new size is 31 by 82 by 120 millimeters. That makes it almost the same size and dimension as this made in China unit. So it's good that they have shrunk that down in the new series. For the input rating, both Cosel power supplies, according to the data sheet, are set by 85 to 264 volts input at 47 to 63 Hertz. So after we do a teardown, we'll be investigating these electrical parameters and we'll see if the cheap China power supply can hold up to a brand name made in Japan, Cosel power supply. It's teardown time. Oh, but look, what's that? It's a QC sticker. Let's take care of that. Much better. Before we take a closer look at the power supplies, let's go through a little bit about the schematic and how these power supplies work. So most power supplies of this class are forward converters and it's a type of switch mode power supply topology. So this is a very basic schematic of what a basic forward converter would look like, and let's go through the main components. We begin with AC. This goes through a fuse. We have some filtering, so we have a common mode choke, X and Y class capacitors, and the AC is then rectified by a bridge rectifier. This is then stored in a large bus capacitor. We will also usually have some sort of integrated circuit, and this will be switching the main power transistor. Now, even though the basic forward converter looks very similar to a flyback circuit, the mode of operation is very different. In this case, the secondary winding is phased with the same phase as the primary, so that energy will be transferred to the output circuit when this power transistor is on. Now, the output of the switching transformer is then rectified and filtered by an output inductor and a capacitor, and this will form our isolated output. Alright, so now I have taken apart both power supplies and I've made a chart on the various components that are inside the power supply. Let's look at them one by one and we can go through the main components together. Alright, now let's look at the cheap Chinese power supply. As you can see, the case is actually quite a nice design, and it's held together by two main screws. And this holds the entire circuit board and the case together. Now, on first impressions, we can see that this is actually made of a very cheap metal and doesn't inspire much confidence, but the good thing is that it is very light. So I have also removed the main circuit board, and this was held together just by two screws as well as a clamp holding the main power devices to the case, which acts as the heatsink. Alright, the construction is generally adequate, and we can see this is a very standard single-sided printed circuit board. It's not the fancy fiberglass materials made of the cheaper kind of fiberglass, but this is in line with the price, especially for $8. So we can follow the main circuit. We have the main power inputs. This has some filtering going on, so we have a common mode choke, we have a capacitor, we have some Y capacitors over here. We also seem to have RTC for some protection, and we can also see an inbuilt fuse over here. For the bridge rectifier, this is just simply comprised of 4 diodes, and then it goes to an output capacitor. In this cheap power supply, we can see that they use a ZSF branded capacitor, and this is 47 microfarads, 400 volts. Alright, now let's go through the rest of the circuit board. This is quite straightforward. There aren't many components on the board. We can see the main control IC over here. They've actually gone through the effort of filing away or sending away the part number of the IC. But that's okay, we can find lots of control ICs that are forward converters, and a lot of them come in the standard 8-bit package. So this is probably just a generic 8-bit package that controls the main forward converter. This is obviously the main switching transformer. So we'll have two main windings. So we have the primary and the secondary over there. And these are the two power devices. Let's take a closer look at them. So in the case of this Chinese supply, we have the one on the left over here is the main switching transistor for the forward converter, and the one over here is the output diode. And this is actually two diodes together with one point connected in the middle. So I went to look up the datasheet. I'm not sure if you can see it, but the main switching transistor is a 2N60 transistor, and this is a 600 volt 2 amp 4.7 ohm MOSFET. This is the main switching diode, and this is a UGF10DCT, and this one is a 200 volt 10 amp switching diode, and all these are rated for switch mode power supply use. This one is actually quite a fast diode at 25 nanoseconds reverse recovery. So we have one optocoupler over here. Now the output of the transformer is then filtered by these two bus capacitors. So these two output capacitors are 35 volts, 470 microfarad each, and I can't really seem to find the brand name. We also have a very small output inductor over here. And finally, if you look at this top part of the board, we have a little potentiometer which we can adjust to set our output voltage. Now, on first impressions, this is exactly the kind of circuit board that we would expect, and let's take a look at some of the things that I found that were interesting about the board. The first was actually the good attention to detail. You can see that they have gone through the effort of actually routing out the board to get a little bit more creepage distance across some of the high voltage parts. So we have some over here. We also have some over here. Just a little bit more isolation. And we have a few other slots throughout the board. So we have one over here, and we have some over here across the opto. So that's a good touch and nice to see. However, there are some other parts of the circuit that are a bit sketchy. So let's take a look at the main transformer. I actually found that this thing was loose and it rattles around, so it might be a good idea to glue it down a little bit. Some of the components also don't inspire much confidence. We can see that the capacitors are all just all over the place over here. They might vibrate loose. It looks like someone just put this in without much care. And also we have this fuse here. It's not inserted properly, as well as capacitors. So generally not very professional insertion of components, but I guess this would work. Now let's take a look at the back. The back over here, generally as what we expected. Again, we can see the cutouts on the board, so this is a nice touch. But other than that, this is a very basic power supply, very basic board, and about in line with what we expected. And I guess it's not too bad for $8. So now let's compare this with the more expensive Cosel power supply. So this is the much larger and much nicer Cosel power supply. And the first thing I noticed when I opened this up was that the entire case was held together just by a single screw, and the rest of this outer casing was held down by little flaps inside which hook onto the bottom of the case. So nice little bit of systems engineering here. We also have a very nice, much more solid metal finish, and this one looks like it's nickel plated. And if we compare this with the other cheap China one, we can see that this one feels of much higher quality and it's much more sturdy. But the downside is that it's much heavier. Alright, so let's get that out of the way, and we have the main circuit board. Now this board is actually very nice, very nicely constructed, and there were a lot of things that I was quite impressed about. The first thing was how they actually used the board as the main back of the board, of the case, as the heatsink, and this was the heatsink for the main power transistors. Now I actually had to remove them because these were held down by clips, in clips like this, and it was actually fairly difficult to remove. But I managed to get those out, so we can take a look at the bottom of the board. One thing I also wanted to point out was the good attention to detail they had. They have this plastic kind of insulating material at the bottom of the board, so it prevents the bottom of the circuit board or the components from touching the case. However, I also note that the cheap Chinese one has a piece of plastic, so I guess that is adequate as well. Alright, so now let's take a look at the main components of the Cosel power supply. So this is the main board, and might be good to have a quick comparison. You can see this is the Cosel power supply is much larger and has a lot more components. So let's take a look at them. For the Cosel power supply, we begin from the AC inputs over here, and this goes through a nice fuse. And the first thing we notice is that there is a lot more protection. So we have a few common mode chokes, we have a bunch of capacitors, we have some very nice Y capacitors, and again, this looks like a much higher quality than the components that were found inside the cheap Chinese power supply. We have a bit more filtering going on here, and this would be our bridge rectifier. Now the next thing that you'll notice is the much larger bus capacitor. In this case, this is a proper brand name Nippon Chemicon capacitor, and we can see that all the capacitors on the board. This one over here, the main output capacitors, they're all Nippon Chemicon branded, as we would expect from a high quality power supply like this. So this capacitor is actually a 200 volt 680 microfarad capacitor, which is significantly larger than the one that we had on the made in China power supply. So for the low voltage side, we have two main power devices over here. So this one is the main switching transistor. As you can see, they use a much larger TO247-ish package compared to the TO220 package. And in this case, this is a Toshiba K2699 switching transistor. And this one is a 600 volt 12 amp and half ohm rated N-channel MOSFET. So this would be the main switching MOSFET into the main switching transformer. So if you look over here, this would be the output diodes for the main switching transformer. And this particular one is, if I can read this, it's a D5LC40. This one is a 400 volt 5 amp diode. Again, the same configuration with two diodes inside and they're connected in the middle. And this one has a reverse recovery time of 50 nanoseconds. So as you can see, this is a much nicer construction. And let's take a look. So we have the main power that comes from the bus capacitors. It goes through the switching transistor, it goes through the main switching transformer, and this output is rectified and sent to our filter capacitors as well as our main inductor over here. And as you can see, this inductor is very large and it's definitely much nicer than the small inductor that we had in this Chinese supply. The main output capacitors are 35 volts 560 microfarads, and they are in parallel, so we have two of them for the output. And finally, I thought this was very nice. They actually went to the effort of making some custom bus bars that connect the output from the transformer and the diode all the way to the inductor. So they actually use this for much higher current carrying capability rather than just relying on the traces on the PCB. So that's very impressive. So one question that you might have is, where is the switching controller IC? So I couldn't seem to find it until I turned the board over, and there it is. So as you can see, the back of the board is actually much more complicated than the made in China one, and there's a lot of other things going on. The main reason is it's using a much more capable IC. So this is the M51995 AFP IC, and this is basically the brain of the forward converter. But it also provides a bunch of other features such as over temperature, over voltage, and over current protection. So now let's go back to the main circuit board at the top of the board. Let me just talk about some of the interesting features that I found inside this board that I did not see inside the Chinese power supply. So one thing that I was quite impressed of was that they actually went to the trouble of adding small ferrite beads over here. So these small ferrite beads take the little edges of the switching transitions, and they have put this on the diode on both legs. They have not only done that to the diodes but also some other parts such as this diode. So they have a little ferrite bead there. So that whacks the EMI on its head. And finally we have some more over here, more ferrite beads. So that's a very nice attention to detail over there. Another thing that's nice was that someone went to the effort of gluing down some of the taller components. So we have some over here as well. So another nice attention to detail. And again, I really like this bus bar over there. They've actually gone to the trouble of doing this, and a custom made bus bar just for this circuit board. And one thing I wanted to note was that this is the ground connection, so this actually screws into the main frame, and they actually use screws with lock washers for this compared to the Chinese one where the board is just connected by a solder joint over here. You might see these interesting features at the back of the circuit board. These are actually spark gaps. As you can see, these are pointy little designs and they have the solder mask removed from where these spark gaps are. Now it might look arbitrary, but actually the distances between between the little spikes are precisely calculated so that in the event of some sort of voltage surge, instead of destroying the components, an electrical arc will form and it will short out over here. And this is actually a very clever way of EMI protection, and it's basically free since you can design it right on your PCB and it will be created during manufacture. Alright, so I hope this teardown has given you a good overview of what it's like inside both power supplies, both a cheap one as well as a brand name one. So now let's go ahead and put them back together, and we'll do some measurements on its output as well as the input voltages that it can run at, and measure the performance in terms of its noise as well as ripple. Alright, so now what we're going to do is to measure the performance of these two power supplies. Now what I want to do is I want to measure how the voltage varies as my voltage input changes from about 80 volts to 250 volts. So this would simulate a variety of input voltages from across the wall. The second thing I want to do is to measure the output performance in terms of its ripple by looking at the waveform of the power supply in my oscilloscope with and without a load. So for this setup, what I have here is I have a variac, and this variac is connected to a voltage doubler here because my line in is about 120 volts and I need the doubler if I want to test it at 240 volts. So this gets fed into the power supply, and then right now what I'll do is I'll measure the output voltage with a multimeter first. So if you look carefully, both of these power supplies have a small voltage adjustment pot over here. So what I'll do first to make sure that both power supplies are calibrated is that I would first power them at 120 volts, and then what I'll do is I will adjust the potentiometer with no load so that I get 24 volts output. Alright, so according to the label on the outside of this Chinese power supply, it should be able to take in 110 or 220 volts plus minus 15%. So what we'll do is we'll measure the output voltage without a load from 95 to 125 volts, and then from 190 to 250 volts. So I've set this to 95 volts, and let's go ahead and turn it on and we'll raise it up. So it seems to do fine at 95 volts input. Let's slowly increase it. 110, 120, 125, and it seems to do fine. So the next thing we'll do is to move it up to 190 volts. So now this is set at 190 volts, and we'll increase it all the way until 250. So it's regulating fine at 190 volts. Let's go up. It's 210, 220, 230, 240, 250 volts. So it looks like the power supply is still holding at 24 volts, and that's good. Now I've added a 20 ohm resistor over here. So this would draw about 1.2 amps from our power supply, which is just about over half of what it's supposed to be capable of doing. We'll do the same test across a different range of voltages. So let's begin at 95 volts. So it's regulating fine at 24 volts. Increase it up 100, 110, 120, 125. That's about 24 volts. Now let's move on to 190 volts. So this is 190 volts, and let's turn it on. Bang on, 24 volts. Increase it slowly. 210, 220, 230, 240, and 250, and it's holding at 24, just about 24 volts. So everything is working as expected, and the power supply checks out well. Now we'll test the output performance of the Chinese supply. I've connected this to my scope. I've set the AC coupling, the coupling to AC, and I've set the bandwidth limit to 20 MHz. This is across the same 20 ohm resistor. So first test at 120 volts input. And as we can see, we see a switching frequency of just about 50 kilohertz, 51 kilohertz, and we have basically everything contained within plus minus 50 millivolts, so that's pretty good performance. Alright, now let's do the same test. This is at 240 volts input. Alright, now this is switch on performance at 120 volts input across the 20 ohm resistor. Switch on performance at 240 volts input. And now let's take a look at the switch off performance. So I've turned this on and now turning it off. Now we move on to the Cosel power supply and we'll do the same test. So for this test, I've set it to 24 volts at 120 volts with no load. So as you can see, it's reading 24.05 volts, so that will be our baseline. Now this power supply claims to be able to take to 85 to 264 volts input, and it should be able to regulate throughout this entire range. So let's set this to 85 volts first. So now we'll turn this on and we'll test the performance of this power supply in terms of what its output voltage is across the entire range without a load. So 85 volts, it's 24.04, spot on. So let's increase it slowly all the way until 264 volts. 100 volts, 110, 130. Let's go up. 160, 180, 200, 210, 230, 250, 255, 260. So the power supply performs well and it maintains 24 volts throughout its entire input range. So I've now added the 20 ohm resistor. This will give a 1.2 amps of load and we'll test it again across its entire input voltage range from 85 volts to 264 volts. So it's at 85 volts, it's at 24 volts. Let's increase it. 100, 110, 130, 150, 180, 200, 220, 230, 255, 265, and it maintains at 24 volts. Now we will measure turn-on performance of the Cosel power supply at 120 volts input across a 20 ohm resistor. Same test at 240 volts input. Now let's measure turn-off performance. Now this is the voltage ripple of the Cosel power supply at 120 volts input. As you can see, there's a few interesting looking features on the output waveform, and what surprised me the most is that it's actually not as clean as the Chinese switching power supply. So this is the same test again, but at 240 volts input. As we can see, now the voltage ripple has increased slightly, and again we can see the characteristic switching frequency. But it's still definitely within the plus minus 150 millivolts according to the specifications. In this case, maybe about plus minus about 100 millivolts. or slightly more if we shift it, so plus minus 110 millivolts. So to conclude, we have looked at the performance as well as the internal construction of these two power supplies. I have to say that I'm actually quite surprised by the performance of this Chinese power supply, and it's not only smaller, lighter, and much cheaper. We actually saw that it has much better performance on the scope. So I hope this was quite educational for everyone to see what's inside small power supplies like these. And it does look like the Chinese one is very good value for money, but we won't know how many years it will last, and maybe components will start failing after a while, but we can be pretty sure that this Cosel power supply would be able to stand up the test of time. So thank you very much for watching, and what do you think?